So the first step would be for the rule of signs is to calculate or figure out how many positive real zeros, possible positive real zeros. Okay. So I know I'm starting with a positive, so I have a sign change, a sign change, a sign change, no sign change, and a sign change. So altogether, how many sign changes do I have for positive? 4. Someone really, really smarter than me a long time ago said that you can actually go, you start, that's your starting number, but you count back by how many? 2. So if I take 2 away from 4, I could also have 2 positive real, or I can have 0. So there are 3 different numbers that we can put in that first column. So when you do your sign change, that tells you how many to start off with. And then you count backwards by 2 until you get to 0. You cannot go negative. So now let's see how many negative real zeros. And what we're really doing is substituting in a negative x. But when you put a negative x into a term with a even power, it stays positive. Only the ones with an odd exponent will flip the sign. So that's why I like to, let me highlight the ones with an odd exponent. It's the exponent that I'm looking at. These 3 terms have an odd exponent, so they will change the sign. So this becomes a negative x to the 5th. The next term doesn't change. A negative 3x cubed. The next term does not change. A positive 4x and a positive 12. So now let's go ahead and count our sign changes. So we have nothing, 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 1, nothing. So the only number I could put here is 1. Because if I try to go backwards, I'm at -1, and we can't have a negative amount of real solutions. So I was trying to remember, because again, we haven't taught this in a while. And I remember someone asked me, how do you know how many rows you're going to have? And that's really depending on what are in these 2. So how many different numbers did I put in this column? 3. And how many in this column? If you take 3 times 1, I get 3. So that tells me altogether, I'm only going to have 3 rows. If by chance I had 3 in this column and 2 in this column, then I would have 6 rows. So I would have to make more space. The only number that can go in this column is a 1. And what number am I putting here? What's my degree? 5. So you can only go back by 2. You can't go back 1. Descartes was really smart. He figured that out. It was before TikTok and cable. So he just practiced and figured it out. He was real smart. So now we need to figure out what goes here. Because remember, the total has to be 5. So here I started off with 5. I already have my 5. So that means I would have no imaginary. My second row, I have 3. And I need 5. So how many do I need to put here? 2. And in my third, I have 1. But I need 5, so I would have to have 4. And that is your Descartes rule of signs. There's 2 of those on the in the homework, and there's 1 on the study guide. All right, so now we're going to talk about potential real zeros. So I'm going to give you a minute to copy down example 6. So we're going to do two of these where we're only going to list the potential, which means we're not finding them. And then we're going to find them. But you want to start by listing your potential rational zeros so you'll know what numbers to test. Okay, so we're not saying that these are the zeros. We're saying this function only has 3 zeros because that's a degree. What are the possible zeros? So to know the possibility, we start by listing all of the factors of P, which this is P. And I'm going to put that over, and there's an invisible 1 right here in front of, that represents the Q. So what are all of the numbers that will divide into 25? It's really not a lot. So we'll always start off with 1, 5, and 25. And what numbers will go into Q? Well, Q is 1, and the only number that goes into 1 is 1. So what this tells us is that the possibilities are going to be let me change that to red. The possibilities will be all of my blue numbers. Excuse me, thank you. The possible rational zeros are going to be all of my blue numbers divided by my red number. So that would be 1 divided by 1, 5 divided by 1, and 25 divided by 1. But it could also be positive or negative. So my possible zeros are positive and negative 1, positive and negative 5, and positive and negative 25. On the test, if it says list the possibilities or the potential, that's what it is. So even though this function only has 3 answers, we have 6 possible solutions. It could be positive and negative 1, it could be positive and negative 5, or it could be positive or negative 25. So after we're going to do one more, and then we'll actually start finding what those zeros are. All right, and I'm going to change this last term to 20. So go ahead and copy this down. And I'm changing that 1 at the end to a 20. All right, so take a minute and copy this example down. So for P, there should be 6 numbers. So there's 6 factors of 20. Mm-hmm. One more time.
1 and 5 or 5?
Oh, you have to always include 1. So it's 1 and 5. 1 is always included. So it's 1, 2, 4, 5. Okay, so for P is 1, 2, 4, 5, 10, and 20. And for Q, it's just 1 and 5. So my possibilities, and I'm going to put plus and minus. So you're going to start off by listing, take all of these blue numbers divided by 1. So anything divided by 1 is just the same. So my possibilities would be plus and minus 1, plus and minus 2, plus and minus 4, positive and negative 5, positive and negative 10, positive and negative 20. Now let's take these same blue numbers and divide it by my second factor of Q, which is 5. So I have plus and minus 1/5, because I'm taking 1 over 5, 2 over 5, 4 over 5. Now, when I start to get to the end, I have 5 divided by 5. But what is 5 divided by 5?
1.
We already got that number, so we don't need to list it. And then 10 divided by 5 is what? 2. We already have that. We don't need to list it. And then 20 divided by 5 would be 4. We already have that. So this would be my list. And this is what I would have to include as my possible rational zeros, all of these numbers. So now that we have that, now we're going to start actually finding them. But you have to know where to start so you don't waste your time testing numbers that aren't even a possibility. So we're going to skip over example 8 and go right to example 9. So we're going to actually find. So the difference in the directions now is that we have to find the real zeros. So we have to find them. And this is a third degree, which means that I'm looking for 3 answers. And I have to figure out what are my 3 solutions. So this is P, this is Q. So let's start off by listing our P over Q's. So the factors of P are 1, 2, 3, and 6. And the factors of Q are 1 and 3. So I'm going to list my possibilities so I'll know which numbers to test. So my possibles are positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. Then if I take those 4 numbers and divide them by 3, I get 2 more. Because 1 over 3 is a possibility, and 2 over 3 is a possibility. 3 over 3 is 1, we already have that, and 6 over 3 is 2, we already have that. So that's my possibilities. So I'm looking for 3 solutions. You have to find one. After you find the first one, we're going to factor to find the last 2. So do you remember yesterday we talked about the factor theorem? And that said that if you put in the test 0, how do you know if it's a factor? What does your remainder have to be? 0. So let's start by testing these first 4 numbers. And I'm going to divide the class in 4, so we're not all doing this. All right, so we're going to start off by testing these 2. So we need to figure out, first of all, and hopefully it's in one of these 4, we need to test f of 1, f of negative 1, f of 2, and f of negative 2. So to make this go faster, I want these 2 rows here to test 1. I want these 3 rows to test negative 1. And then I want this group here to test positive 2, and then negative 2 over here. And I just need to see which group gets a 0. And if none of those worked, then we would go to the next 4 numbers. 3, negative 3, 6, and negative 6. Yeah, we're plugging it. You're going to plug it into this function. Don't say it out loud. I want everybody to practice. And then there's some by the window, too. I don't know why. I'll put them up on the desk. So that's what you're going to do on the test. When you have to do this on your own, you list your possibilities, and then you start testing. If you're lucky, 1 will work. Then you don't have to test no more. Or negative 1 will work. 2, negative 2. So for f of 1, what was your remainder? Who was my 1 group? Still working? You got negative 15? Negative 16? For f of negative 1, what did you all get? 12? For f of 2, what did you all get? For f of negative 2, what did you all get? All right, so which one of these numbers am I going to use? The 2. So 2 is a solution. So I'm going to list that at the top. Degree, your degree. So I'm looking for 3 solutions, and we need to find the last 2. So now we're going to go back to algebra 2, and I'm going to remind you of synthetic division, because that would be the easiest way to get the last 2. For those of you who did not take algebra 2 last year, this is the easiest form of division. You put your 2 on the outside, and then you only list the coefficients across the top. So I'm going to list my 4 numbers. So it would be a positive 3, positive 4, a negative 17, and a negative 6. Raise your hand if you remember this from algebra 2. Okay, a couple people. So for synthetic division, you bring down that first number. You always just drop down the first number, which in this case is a 3. And then you take this 3 and multiply it by your 0. So 3 times 2 is what?
6.
Put that under the next number, which is 4. And then you add these together, 4 plus 6, and that gives you 10. Take that 10, multiply it by the 2. 10 times 2 is?
20.
Put that under negative 17. You add negative 17 plus 20, and you get 3 times 2 is, and you'll know it's right because you should also end with a 0. If you don't end with a 0, then you did it wrong.
What did you find before negative 17?
So these numbers up here, these 4 numbers are the coefficients of my factor of this 3, 4, negative 17, negative 6. Group 2 told me that that was a factor. That's why this went out here. And then you just bring down the first number, multiply, put that here, add. Multiply, put that under the next number, you add. Multiply. Okay, so these 3 numbers, does anybody remember what this is? That's A, B, and C. So this represents 3x squared plus 10x plus c. Go ahead and factor that down. I did not mean to put c. Plus 3. That is my quadratic that we have to factor. Factoring is one of the foundational skills of algebra, of pre-calc. Like, you have to know how to factor. And that's how you find your other 2. So let's make your box. Put 3x squared here, and a 3 goes here. You would need 2 numbers that multiply to 9 and add to 10. So that would be 1 and 9. Go ahead and finish it out. Factor it and get your last two solutions. So your last two factors will be 3x plus 1 and x plus 3. So if you said 3x plus 1 equal to 0, you get x equals negative 1/3. If you said x plus 3 equal to 0, you get x equals negative 3, which was also in our list of possibilities. So we found all three of our solutions for this particular function. And it would be x equals positive 2, x equals negative 1/3, and x equals negative 3. Yes, and it's worth a lot of points. All right, so we're going to do one more, and then we'll end there. So it's kind of like we're building this snowball. So we started off with, okay, well, how do you know how many zeros you have? First, how do you know if it's a factor? And now let's find our factors. So it's a lot of algebra being pulled back in. So we have one more question for today, and then we'll end there. So what I want you to do for this next question is start off by finding a list of your possibilities. So we have P over Q. Go ahead and list your functions. All right, so for my factors of P, that would be 1 and 2. And my factors of Q are just 1 and 3. So my possibilities are plus and minus 1, plus and minus 2, plus and minus 1/3. Sorry, not 1/3, sorry. Yeah, plus and minus 1/3 and plus and minus 2/3. So how many solutions am I looking for? How many? 3, because your degree is 3. So let's list that. So let's start testing. So I'm going to divide it again. So who remembers what group you're in? So we got f of 1, f of negative 1. So we'll do... I think 1 or negative 1. How about we say this side of the room test 1 and this side of the room test negative 1. When I do synthetic division, if 1 is my answer, then that means it's 1. A 1. So for the side that got 1, who put in 1, what did you all get? 0. For the side that put in -1, what did you get? So that means that this is a solution. So x equals 1 is my first solution. So now we're ready to do synthetic division. So I'm making my bracket. Put that 1 on the outside. And then you're listing these numbers here. 3, +4, -5, and -2. Go ahead and try to do synthetic division by yourself. See if you can. You should get a 0 at the end. Who did synthetic division and ended with a 0? Oh, that's good. All right, so we're going to bring down that first number. So 3 times 1 is 3. That would go here. And then you add, and you get 7. 7 times 1 is 7, so that would go here. And then you add, and you get a 2. 2 times 1 is 2, and you add, you get 0. So this will be your A, B, and C. So let's go ahead and factor that down. So factor 3x squared plus 7x plus 2. I'm going to make your box. 3x squared goes here, and 2 goes here. You need 2 numbers that multiply to 6 and add to 7. Go ahead and find your last 2 solutions. So your last 2 solutions are -1/3 and -2. And that would be your solutions. And that is that.